I'm Amit. I work at VMware, and I am working in Kubernetes and specifically focus into long-term support, extended support, anything you call it. I have been a contributor to other open source projects, for example, OpenEBS, if anyone has heard of it. Meta controller, again, these were like some of the things that I was hands-on in my couple of years ago, not now. Let's get on to the topic first, because I don't want to get you bored in the last session of the day. The picture here looks bright, colorful. It kinds of gives us a moment of happiness. And why not? It's all about sweets, chocolates, candies. However, things turns to be different the moment we look at that particular line, which is, I'm hoping it's visible. It's all about the vulnerabilities, right? And the metaphor here for the colors is the category of vulnerabilities. Like, there can be different categories, for example, catastrophic, critical, high, low, medium, not exploitable, and so on. Now, getting back a little to the first slide, the stuff that is shown here represents, packages, software packages, right? They can be in various forms. They can be, libraries. They can be compilers. They can be programming language, runtimes, and there can be multiple variations of it. For example, there can be different versions. There can be, take an example of Golang compiler. It can be like 1.19.x, 1.20. Maybe there are some distros who maintain really, really old versions of Golang compiler. It may be 1.11, 1.12, and so on. The point that I'm going to make here is there are a lot of packages, right, which can outnumber the lot of teams that are present in an organization. For example, a package count in a distro can go up to 1 lakh or even more than that. And imagine if if a bunch of packages, or if, let's say, one package has 10 vulnerabilities, the number of vulnerabilities in the entire distro can be, humongous. It can be, very difficult to handle and maintain. So we move forward. This also denotes the use case or the kind of problem statement that we had a few months back. We had an internal product that consisted of around 100 microservices, more than 100 microservices. And when the security team started auditing these images, this entire product, they started to run scans. They started to run with various scans, right? And there was this numbers, like we were getting 10,000 plus vulnerabilities, and we were asked to do something about it. This resulted in a Jira ticket. The Jira ticket, the title of the Jira ticket said, hey, just move all the images to Distroless. And it just sounded like once we move each of these images to Distroless, we would be done. All the images would go back to normal state. We may not have, we may not have 0 vulnerabilities, but it should be definitely not be in thousands and 10,000s. It may be in some handful of numbers. However, we realize that not all images, not all applications can be compiled and put into the Distroless and be done. There are only specific applications which are fit for Distroless, right? And those applications were something like, for example, again, I go back to Golang-based applications, which are mostly statically compiled, self-contained binaries. They don't have any dependencies. They don't have any external dependencies, right? So they can be bundled up. The entire compiled binary can be put into a Distroless image. Take one of the flavors of Distroless image, package it, and ship it as a deployment unit, and we are done. Most of the scanners would say 0 or very negligible number of vulnerabilities. But what about the others? right? Not every application is Golang based, or not every Golang based application can be considered as a statically compiled one. There are definitely applications which need external dependencies. They are dependent on the external dependencies, shared dependencies. Even there are applications who need specific dependencies to run at the runtime, right? So, you know, and all applications are not equal. And that is the problem that we had and the challenge that we were about to solve. This led us to, you know, a brainstorming session where we thought, hey, let's try to, you know, get into the distroless mode, right? Get into the, you know, the toolings, the ingredients used to build distroless images, and maybe we can come up with something better. And why not? I mean, if at all we can have some, I think it's having a little bit of pain here. Okay. So yeah. So we had this brainstorming session where we thought if we can, you know, do a deep dive into the distroless, the ingredients that make up the distroless images, maybe we can come up with something better for our images, perhaps with some, you know, new tools or some add-ons that we can include along with the distroless images to get our job done. All right. So this was our first attempt, and by the way, this is directly from the Fluent Bit source code. This is still available in the GitHub in the master branch. What we see in this is this is like again the multi-staged Docker build. In this slide, we see the two stages. The first slide represents you know, installing the dependencies so that there is an environment which can build the Fluent Bit source code. The second stage is all about actually compiling the Fluent Bit source code. They happen to make it, they happen to split it into two stages so that it can be cached, right? If you see the later stages, the third stage is something that the Fluent Bit, you know, maintainers have, you know, thought a little bit deeper into the things. You know, they have understood the mechanics, how Debian works. In other words, what they do here is they download the .deb files instead of installing, you know, the packages. They download the packages as Debian files, .deb files. They iterate through them. They have a, you know, the list of those packages, and then they set up some status so that the scanners can understand what exactly they were doing. Right? The scanners will be able to figure out what exactly are the dependencies that are getting installed into the image so that when they scan, they can come up with the particular reports, with the scan reports. The last one is again very important. All the initial stages that we have seen, those were based out of Debian. So of course, they'll be having the package managers, bash, and all those things, which again are all build-time dependencies and not runtime dependencies. However, the last one, it's distroless. It consists of only those dependencies that are required to run Fluent Bit in this particular case. And what we see here is they just copy from the earlier stages. In this case, they copy the Debian packages, they copy the certificates, they copy the Fluent Bit binary, and that is it. They get their job done. This is, again, they're all aligned with the distroless principles, right? Even there, I'm sure there will be many teams who would say, I mean, this is all fine, right? If we start to run the final image against the scanners, I'm sure it would result in very less vulnerabilities. However, is that enough? What about, you know, the supply chain security? I think there was some mention about that. What about the reproducibility aspects of this thing? We well know that the Docker images that we produce, right, they are not, you know, reproducible. For example, if we try to run a checksum against an image, right, and we build the image once again and run the checksum, it will give two different results. So that's the kind of reproducibility that I'm trying to talk about here. So finally, we realized that, we can do all the customizations against top of Distroless, right? But we cannot get to a state where we can have all these supply chain security benefits as well. It needed, some different thinking, maybe perhaps some new toolings, which we might have to build, or maybe we can take from the community. All right, so thus our journey started, and these were the series of blogs which actually opened our eyes. For example, it gave us different tools. It made us realize that it's not just the Docker file or the builder and so on, but there are different other tools out there, and almost every one of them is open source, but they have like different thought processes, different principles. Once we are sure that once we are sure about the basics that we needed to build these new tools, or adopt any of the new tools to get to the Distroless variants of our images, we thought, let's give it a try, and let's see like if we can, get something done with these new found knowledge. Again, like these were some of the lists that I could remember, and among them like Ulfi. I guess most of us here would be aware of Ulfi. It's again from the chain guard, from the forks of chain guard. Again, the forks from chain guard are the ones who were originally the developers of Distroless. There is also a build packs, and there is something called Chisel from Canonical. It's relatively new. I found it like late last year. But that is something called Nix, which stands out. I'll get back to Nix in a while, but let's start from the build packs. Okay, the moment the moment I looked into build packs, how it generates these images and how it manages the supply chain security, and if it is a good candidate for us to filter out all the non-related dependencies and only depend on the specific dependencies that the application needed, what we have to do, and while cloud build packs or the build packs, they do their job, but then I also saw like their site listed several other options, right? For example, CodeGib and all, which gets the job done. It's kind of a checklist which an organization or a team can start looking at, and if it fits their requirements, they can go ahead with one of them. Again, like we did not focus on these tools. Rather, we focused on Nix. For some reason, Nix made more sense to us because of its inherent design principles. It is by the way, Nix is a language, is a package manager. It can be called as a distribution, a distro. Those are some of the characteristics of Nix. But if you look at the principles of Nix, right, it's all about the builds, the way we can build the source code, and while building the source code, we see that those source codes can be reproducible. Once we build it on a particular workstation, and we try to replicate that build in some CI/CD system, or maybe our coworkers, our colleagues' workstation, they all should be same, right? So that we can guarantee that the builds that are produced from a CI/CD machine are exactly the same that are being run by the users in their production environments. So that's the provenance that we are talking about here. And there were like various other things which made us wonder if we should move on to Nix, just because some of the things like Git, right? Git, for example, it showed us a way where we can make use of Git, the commit history, the commit revisions effectively while building the source code. We'll come to that in a while. We'll see the investigations while we're doing it. So now we are at a phase where we will look at a few of the Nix code base, and we'll see how we will be using this particular scripts to generate images which are at par with the Distroless images, right? And it's not just the Distroless that we are after. Remember, we are also after the supply chain security benefits. We also want to, tick mark the SALSA level 1, 2, and 3. So in this particular case, what we have done is we were actually building up an environment that consists of curl, and just to add, along with curl, I added certificates bundle as well. Remember, because it is a Nix environment, whatever packages we add here, it's not just a download of the packages. It will download, it will get it built from the source code. For example, curl will be in some kind of Git repository. CSRts will be in some Git repository, right? So it will go to that Git repository, download the source code, build it in a sandbox environment where it doesn't have any access to the internet, right? So that the build is pure, right? And that is like a one path. However, if the binary is already built by someone, and if it's cached, it will get the cached binary downloaded, checksummed, and hence try all the tricks, all the techniques available to make it reproducible. So that was purely about Nix. Now, how can we convert it to a container? This is again this is one of the ways. This is not the only way to convert it into a container. We can go we can mix Nix with Dockerfile to get to a OCI image. We can use Nix inbuilt functions to produce an OCI image. There are multiple options. In this particular example, right? What I have tried is I have tried to make use of the the previous Nix file, bundle it into a base image, into an image where the first stage of the image has Nix and all these binaries, right? In the second stage, we just copy the the resulting binary, put it in appropriate places, and get the things done. Right. Now again, we are at step 3 where we try to run the resulting binary against different scanners. What we saw here is not just a curl but its dependencies. For example, OpenSSL was coming up and showing up various vulnerabilities, not just with a single scanner but multiple scanners. So the the columns at the last, the 3 columns at the last, they signify 3 different scanners, right? Gripe, OSB, and Vuln. There is one scanner called Vuln, right? So the the key takeaway here is there may be different scanners coming up with different criticality, right? It is up to the team or the organization, to have a, to look back at the rules, on the policies, where they would call a vulnerability or a vulnerability as maybe as a low vulnerability. This is again one of the ways where they can do an aggregation. If there are more than one scanners who are reporting it as, who are marking it as a vulnerability, then believe it as vulnerable, as a vulnerable code, make do exceptions or see if it has been fixed in the upstream. But again, the caution that I wanted to say here is this is one of the ways where you can tag a particular CVE as vulnerable or not. So now we thought that if at all this particular curl package is having these many vulnerabilities, I think this is 17 in number. How do we reduce these vulnerabilities, right? The next thing that we tried is we tried to bump the OpenSSL. Again, the steps that I'm showing here is very similar to the ones that we can do it in Dockerfile. We bump the distro. In this case, we are bumping the distro. Here it is the Nix packages. And I'm bumping that in a different way. I am bumping it by, picking up a particular commit. The commit where I know contains the OpenSSL version 3.0.8. To again, recap, we are getting these vulnerabilities in OpenSSL version 3.0.7. And we are, bumping the OpenSSL in this particular way, which is a Git-friendly way. All right. So what we see here is obviously, after the the bumping, we found that the number of vulnerabilities in the OpenSSL dependency has decreased. and at the same time, we also see that the number of vulnerabilities found in the curl, like earlier, it was like 4 or 5 different, vulnerabilities, but now it has started to report, 2 vulnerabilities. So it just says like it may not be the specific package that we are interested, but these vulnerabilities lie deep down in those, external dependencies. So this was a good investment. I know we thought, okay, this is good. Maybe if you scale it out to different to those 100 odd microservices, maybe it will give us a better results. And then the next step that we did was, how about bumping the curl to the next version? So again, what we did was we started to figure out the commit, right, which had one of the latest versions of curl, right, and we just go ahead and do that. And we also saw that this particular commit number, these had curl 8.0.1 as well as the previous version of OpenSSL, which is 3.0.8. So we don't have to it's like the later version. And now what we see is all the vulnerabilities reported against curl were gone, right? And what remains is 3 vulnerabilities all tagged against OpenSSL, right? Again, if you see at the top, we started with 17, then after bumping OpenSSL to the immediate version, right? It reduced significantly to 5, and now after bumping curl, we are now at 3. Can we do anything else, right? At this point, let's say here the comparison stops. Like if we were at using our traditional distros, for example, Debian or anything, what can we do other than bumping, right? We can go and maybe check out the source code if the source code has the patch, right? Or we can get the patch as a .patch file and patch it against, try to backport it against one of the older versions of curl or maybe one of the older versions of OpenSSL and build it and get it done. But this seems to be an arduous task. This is like too much for a development team to take up, right? And I'm sure most of the development teams here, they don't deal with curl or OpenSSL. Now, however, with Nix, we still can go ahead. We can still do something better. So what we have done here is we are overriding, right, the Nix. We are overriding the OpenSSL package that is present in Nix distribution with the OpenSSL source code, which is present in the upstream, by hooking it up with the version. We are not looking into the commit number, but with just the version, right? This is enough. This is enough to bump the OpenSSL further to 3.1.0. And then we will see like if things work and if the number of vulnerabilities do decrease. Again, like this is one way. The other way would have been, to prepare a .patch file, make it as an overlay here. That is also possible, and do the build. However, we did not go into that route. Rather, we thought, let's do an overlay. Overlay here implies override, and go to the OpenSSL source code. We are not, by the way, we are not really going to the OpenSSL source code. It's a Nix packages which will be internally be downloading the source code from OpenSSL and doing the build and stuff like that. There's some more points to note here, like OpenSSL, libSSH. We are now dealing into the guts of OpenSSL, the guts of curl. Now you may be wondering like, how will a developer know about all these things? So there are different toolings, there are different CLI arguments available in the Nix CLI, which can get us these exact dependencies, a dependency tree, and we can actually see, okay, OpenSSL 3.1.0 is dependent on this library, and hence we need to see like if the compatibility is there or not. So there are toolings available to get us to this point. It's not easy. It's not direct. As a developer, we had to figure it out. And the main advantage here is there is a possibility. There are options to get this done. However, we still saw that the number of vulnerabilities did not change. In fact, the vulnerability IDs were same. Again, this was an attempt that we took just in anticipation to see if the vulnerabilities can be made to 0, but it was not the case, mostly because this vulnerabilities has not been fixed in OpenSSL in that particular version. And we did not want to go to OpenSSL, master branches, because that would be too much for a normal team to, undertake and get the compatibility matrix validated, right? So we stopped here, right? However, is there any other thing that we can do? Can we rethink this in a different way, right? What about dumping OpenSSL, right? Is it possible? Can we have a curl without OpenSSL itself and just eliminate the vulnerabilities, right? By the way, for those who have been following ChainGuard or Wolfie, you might have seen some of the blog posts where they say they are the first ever distro which has implemented a lot of memory-safe languages, a lot of memory-safe implementations of packages, right? So this is one of the techniques they use in different ways, but in this particular, slide, what we are seeing is we are dropping OpenSSL, and instead we are replacing that with Rust TLS. Now, a little bit of history here, or a little bit of a background. Curl has a concept of backends, and one of the backends is TLS. Okay, the moment the concept of backends come, a particular implementation can be replaced with another implementation. Okay, and Rust has Rust provides a couple of them. TLS is one such backend. There are other backends as well, and we just start experimenting with one of those backends, that is a TLS backend. We replace OpenSSL and put that and replace it with Rust TLS, which is a memory-safe implementation. Now, I did not come up with the number of CVEs that was there. It resulted into different CVEs and stuff like that. There was other things that we had to do. But if we just stop here, right? We already have got a version of curl, a binary of curl, which is memory safe, or at least from the TLS perspective, right? And we thought, like, this is really good. This is something that we could have never imagined to do it in Docker files, or let's say with those traditional distros. We can still do it, but I think those Docker file will really become long, maybe 500 to 1,000 lines of code, and nobody would like to maintain such a file, right? Yeah. So we are almost at the end here, at the takeaway session. What we see here is, obviously Dockerfile solves the needs of specific teams. Let's say depending on specific applications. But then Dockerfile has a long way to go when it comes to the supply chain security. We can say that, hey, we will use Dockerfile, plus we will use some other tool, plus we'll use some other tool to get everything secure from the supply chain perspective. Tick marking the SASA, levels. That is one way, but I don't know how good that way is, unless and until we have the Dockerfile littered with wget, curl, and all sort of, download the stuff from internet, making the builds impure. So one of the things that we would like to say here is, focus on tools which are designed from the supply chain perspective, which actually, can give you the supply chain benefits, the supply chain security benefits, right? The third one is about, Distroless the image versus Distroless the tool. For example, in this particular session, we talked about Nix as one of the approaches, right? We could have gone into Bazel, for example. I know, like, it will raise eyebrows, like it has a steep learning curve and all, but we need not look into those semantics and syntaxes and all. Maybe we can, focus on specific areas. For example, the OCI rules, right, of the Bazel. Maybe we can focus on OCI rules and get the job done. Perhaps that will be, maybe that is also a way to build a Distroless image customized for the team, right? And of course, that would be even a great reference for those organizations who trust, who have like blind trust in Debian. Obviously, Debian has been there for decades. It is trusted for its security. right? There are some organizations who have a policy to just use Debians, to just depend on Debians and nothing else, right? For those organizations, it would be a great fit, right? And then coming to the to the last let's say column. What I see here is, and what we did here is that Nix plus Dockerfile is not the only one option. We can have Nix plus Bazel. Nix for when I say Nix plus Bazel, Nix can be used as a tool to get the external dependencies, whereas Bazel can be used as a kind of a meta tool to build your applications. And the end result will be a compilation unit which has all those ticks when we talk about supply chain. Again, like Nixpacks is yet another project that I'm seeing from one of the end user companies who have already tried with build packs. They have failed, and then they moved on to something. They designed this on their own, so they have Nix and build packs concept combined together to get to the compiled binaries which are secure. Again, I'm noticing the trend of having depending on this hybrid or more than one tool by those organizations that are at a maturity level, which have already used these tools. For example, they maybe some years ago they have dependent on Dockerfile. They failed with the supply chain benefits. They could not get the supply chain benefits, and their team is at a performing level where they can rely on the team to get on to the new needs of the organization, where they start experimenting with these things. Again, so this was one of my observations when I saw there are specific organizations which are making use of these hybrids to get to the to their end goal. Yeah, so these were some of the references. In fact, the slides about Nix that we saw here, we can see the exact commands used and all in the first hyperlink. The others are available in the internet, and anyone can have a look. When the slides are available. Yeah, so it's a wrap. So I am done. If there are any questions, I'm happy to take, or maybe we can meet outside if that's how we want to continue with this thing. Thank you.